Hello friend, this is the CET paper last year, first day, first batch. I had solved all the examples in a very simple language. I hope that you will understood all the problems. Now let us start. The first question. If f of x is equals to 3x minus 2 and the g of x is equals to x square, then find f o g of x. The first is three x minus 2, second 3x square plus 2, third option 3x square minus 2, and fourth is 2 minus 3x square. Now this is very simple question. It is from the 11th standard. म्हणून सीईटीच्या अभ्यासासाठी 11th and 12th सगळं टेक्स्टबुक तुम्हाला आलं पाहिजे. Each and every examples from the textbook. That is f o g of x. That is f of g of x. But what is the g of x? It is x square. And what is that? That is equals to 3x square minus 2, and hence option 3 is the correct one. Question number 2. But before that, we will see again the solution. Here is a, if f of x is equals to 3x minus 2 and g of x is equals to x square, then find the f of g of x. That is the g of x is x square. And but what is the f of x? F of x is a 3x minus 2. Therefore, it is a 3x square minus 2, and hence option 3 is the correct one. See this again here. Next. Question number 2. The number of solution of sine square theta is equals to 1 upon 2 in closed interval 0 to pi is three first, second option 2, third is 4, and fourth is 1. Therefore, the solution is a sine square theta is equals to 1 upon 2. That is equals to sine square theta is equals to 1 upon 2 is equals to 1 upon 2, 2 bracket square. And that is nothing but the sine of pi by 4. Now the function is f of x is equals to 3x square minus 2, g of x is equals to x square. Then find the f o g of x. The first option is 3x minus 2. Second is 3x square plus 2. Third is 3x square minus 2. And fourth is 2 minus 3x square. Therefore, f of g of x is equals to f of g of x therefore g of x is x square and the f of x is 3x square minus 2. And therefore option 3 is the correct one. That is a 3x square minus 2. Now again you can see this also here. If f of x is equals to 3x minus 2 and your g of x is equals to x square, then the f of g of x is equals to, that is f of g of x is equals to f of g of x. G of x is x square, but what tells the f of x? F of x is 3x minus 2. Therefore it is a 3x square minus 2 and hence option 3 is the correct one. Now the next is second. The number of solution of sin square theta is equals to 1 upon 2 in closed interval 0 to pi is the first is 3, second 2, third is 4, fourth is 1. Now the solution is, now see this here, sin square theta is equals to 1 upon 2 is equals to 1 upon root 2 bracket square, and 1 upon root 2 is nothing but the sine of pi by 4 bracket square. Therefore theta is equals to pi by 4. We are using the result that sin square theta is equals to sin square alpha, and it implies that x is equals to n pi plus or minus alpha where n belongs to z. We get x is equals to n pi plus or minus pi by 4. In 0 to pi, only two solutions therefore the 2 is answer. Now we can see this also here. That is the number of the solution. We can write it like this. Using the result sin square theta is equals to sin square alpha, that is it implies x is equals to n pi plus or minus alpha, n belongs to z. Therefore we get x is equals to n pi plus or minus pi by 4, and in 0 to pi only the two solutions are there, and hence the option 2 is a correct one. Next is question number 3. If A bar plus B bar, B bar plus C bar, and the C bar plus A bar are the coterminous edges of parallelepiped, then its volume is, these are the edges, first is 0, second is 3 in the box product, that is A bar, C bar, B bar, third 2 in bracket, square bracket, A bar, B bar, C bar, and the fourth is, that is a 4 in bracket, B bar, A bar, and the C bar. This is the box product. We have given that is a, if A, B, C are there, then A bar dot in bracket B bar cross C bar. By using that formula, we have in first bracket A bar plus B bar dot in bracket B bar plus C bar cross in second bracket C bar plus A bar. Therefore, we make the product, that is here B bar into C bar, B bar into A bar, C bar into C bar, C bar into A bar. Now here C bar into C bar, that will become 0. Next, A bar plus B bar, B bar cross A bar plus B bar cross A bar plus C bar cross A bar. Now this next is A bar dot in bracket B bar cross C bar, A bar dot in bracket B bar cross A bar, and the last is A bar dot in bracket C bar cross A bar. Now here these two products will be 0 because A is a common here. This will be also 0. Therefore 0, 0. This will become 0, 0, and this will be remain only. Now A bar dot in B bar cross A bar. All the remaining will be 0. Now see this is the cyclic product, that is B bar dot in bracket C bar cross A bar can be written as A bar dot in bracket B bar cross C bar. If you add the, then you will get 2 times in bracket A bar dot in bracket B bar cross C bar, and this is nothing but the box product, that is A bar, B bar, C bar. That is the third option is the correct one. Okay. Here. It is on the page number 153 from the textbook. Volume is equals to, you can write here their product. Therefore here only the remaining terms are A bar dot in bracket B bar cross C bar plus B bar dot in bracket C bar cross A bar. If you add these two, then you will get 2 times A bar, B bar, and C bar. Now the next is, that is option 3 is the correct. Question number 4 from the integration. Integral, that is in root of x square minus x square upon x dx is equals to in root of x square minus x square minus a cos inverse of x upon a plus c in root of x square minus x square plus 1 upon x cos sec inverse of x plus c in root of x square minus x square plus a sec inverse of x upon a plus c, and the fourth is x in root of x square minus x square minus 1 upon a tan inverse of x upon a plus c. Now this is on the page number 159. It's a solved example. Put x is equals to x a sec theta. Therefore sec theta is equals to x upon a and therefore also theta is equals to sec inverse of x upon a. Now x is equals to dx is equals to, that is a sec theta into tan theta into d theta. Therefore I is equals to integral a square sec square theta minus a square a sec theta into tan theta into d theta. Therefore integral, take a as common, sec square theta minus 1 a sec theta into tan theta into d theta. Now the cancellations of the terms are sec theta get cancelled. That is here sec square theta minus 1, it is a tan square theta, and overall it becomes tan theta, and this tan theta into tan theta, it becomes tan square theta. This sec theta get cancelled. Therefore you will get a integral sec square theta minus 1 into d theta. Therefore integral of the sec square theta is a tan theta minus theta plus c. The value of the tan theta is in root of sec square theta minus theta plus c. Therefore a in root of x square minus a square minus 1 minus sec inverse of x upon a plus c. Therefore the correct is x square minus a square in root of minus a cos inverse of x upon a plus c, and hence option 1 is the correct one, that is in root of x square minus a square minus a cos inverse of x upon a plus c. Now again we will see this here. The solution, put x is equals to a sec theta is equals to x upon a, theta is equals to sec inverse of x upon a, d theta is equals to a sec theta into tan theta into d theta. Substitute the values in this integral, that is I is equals to in root of, that is in root of a sec square theta minus a square upon a sec theta. Therefore it is a sec square theta into tan theta into d theta, and if we solve this, then you will get, that is sec square theta minus 1 sec square theta, integral of the sec square theta is a tan theta, integral of the 1 is theta. Substitute the value of tan theta in root of sec square theta minus 1 minus theta plus c. Substitute the value of sec theta, that is in root of x square minus a square minus 1 minus sec inverse of x upon a plus c. That is nothing but, if we evaluate this, that is a in root of x square minus a square upon a minus sec inverse of x upon a plus c, and hence the option 1 is a correct one. Now the next is the minimum value of z is equals to 10x plus 25y subject to where x lies between 0 to 3, y lies between 0 to 3, x plus y is greater than or equal to 5 is 105, 80, 30, 95. Therefore the first is the graph. The first line x plus y is greater than or equal to 5. These are the line x is equals to 3, y is equals to 3, and therefore you will get the point of intersection 3, 2, 2, 3 and 3, 3. This is the visible region. These are the points. Therefore the first at the point A, 10x plus 25y, that is equals to z of 80. The first is. For this point B, z is equals to 95, z of b is equals to 95. At the point C, x is equals to 3, y is equals to 3, and that is equals to 105. Therefore, the second option is the correct one. We'll see the answer here also. See this here. The minimum value of the z 10x plus 25y subject to the value of the x lies between 0 to 3 and y is 0 to 3. X plus y is greater than or equal to 5 is 105, 80, 30, 95. This is the equation. X is equals to 3, y is equals to 3, x plus y is equals to 5. These are the points of intersections of these two lines. A is 3, 2, C is 3, 3, B is 2, 3. Substitute the values at the z. Z of A is equals to 80. Z of B we have 95. Z of C is equals to 105. And therefore the second option is the correct one. Question number 6. If f of x is equals to 3x cube minus 9x square minus 27x plus 15, then the minimum value of f of x is 30, second 66, minus 66, plus 66, minus 30. Now this is the problem from application of the derivative. Now here f of x is equals to 3x square minus 9x square minus 27x plus 15. F dash of x, first we find out the it's a derivative. That is equals to 9x square minus 18x minus 27, then equal to f dash of x is equals to 0. Therefore 9x square minus 18x minus 27 is equals to 0. Take common. Then you will get x square minus 2x minus 3. In the first bracket you will get x minus 3. Second is x plus 1 is equals to 0. X minus 3 is equals to 0 or x plus 1 is equals to 0. X is equals to 3 or x is equals to minus 1. Second derivative, it's 18x minus 18. And at the point 3, that is 18 into 3 minus 18, that is equals to 36, which is the positive. F of x is a minimum at x is equals to 3. That is a 3x cube minus 9x square. It's a minimum value. We'll find out it. Substitute the value. X is equals to 3. This is the calculations. That is minus 66. Double dash of x is equals to 18x minus 18. At the minus 1, which is negative, minus 36 less than. The maximum value of f of x as x is equals to minus 1. That is the 30. Hence the option 1 is the correct one. Now again we will see this answer. The function maximum value, the given function, its a derivative, that's equals to 0. Factorize it. X is equals to 3 or x is equals to minus 1. Second derivative, it's a positive, that is a plus 36. F of x is minimum at x is equals to 3. So minimum value is a minus 66. F double dash at x is equals to minus 1. It is a minus 36 negative. It's a maximum at x is equals to minus 1. And its value is a 30. And hence the option 1 first is correct. Now the next is question number 7. The general solution of x into dy by dx is equals to y minus x into tan of y upon x is, the first is x into sine of y upon x is equals to c, x square into sine of x upon y is equals to c, x into sine of x upon y is equals to c, and fourth is x square into sine of y upon x is equals to c. Put y upon x, y is equals to vx. Now differentiate this. Therefore, dy by dx is equals to, by applying the product rule, derivative of x is 1 plus x into derivative of v, that is a dv by dx. Therefore, x into dy by dx is equals to, substitute the value, that is the value of the dy by dx is equals to v plus x into dv by dx. Y is vx minus x into tan of v. And simplification, normal simplification is here. That is x into v, vx on both sides get cancelled. Then you will get x square into dv by dx is equals to minus x into tan of v. X into dv by dx is equals to minus tan of v. Separate the variable, that is dv upon tan of v is equals to minus dx upon x. Integrating, that is the, now on both sides, the 1 upon tan of v is nothing but the cot of v into dv plus dx upon x is equals to 0. Integrate on both sides. The integration of the cot of x is the log of sin x. Log of x is equals to log of c, because all are in the form of the logarithm. Therefore, we write here log of c. Again, by using the rules of the logarithm, that is the log of x into sine of v is equals to log of c. Therefore, x sine of v is equals to c. Therefore, substitute the value of the v, x into sine of y upon x is equals to c. And therefore, option 1 is correct one. Then we will see the total solution of this. The general solution of x into dy by dx is equals to y minus x into tan of y upon x. These are the options. That is, put y is equals to vx, their differentiation, apply the product rule. Therefore, you will get, substitute the value of the dy by dx, cancellations, x square dv by dx minus x tan of v, x into dv by dx minus tan of v, dv upon tan of v is equals to minus dx upon x. And after the integration, I have to solve that. Then you will get, that is x into sine of y upon x is equals to c, and hence option 1 is a correct one. Now next is question number 8. Which of the following is not equivalent to P implies Q? P is sufficient for Q, Q only if P, P only if Q, Q is necessary for P. Therefore, the conditional statement P implies Q, P is sufficient for Q. Second, Q is necessary for P, P implies Q, P only if Q, Q follow from P, therefore the P is sufficient for Q. Second is also correct one. Q only if P is not equivalent. Now see this. These are the first is correct one, second, fourth. That is a Q only if P. This is the answer. That is a not equivalent. Next is, if the function f of x is equals to a log of 1 plus ax minus log of 1 minus bx upon x is continuous at x is equals to 0, then f of 0 is a plus b, second log of a plus log of b, third log of a minus log of b, fourth a minus b. As the given function is continuous, f of 0 is equals to limit x tends to 0 f of x, limit x tends to 0, log of 1 plus ax minus log of 1 minus ax upon x, separate it, therefore limit x tends to 0, log of 1 plus ax upon ax into a minus log of 1 minus ax minus ax upon minus ax. The value of this limit is 1 into a, and the value of this limit is 1 into b. I had forget to write it, but I will write now. That is f of 0 is equals to a plus b. Now see this here. One thing I forget here to write here. Here must be b here. By mistake I had written here. I had corrected here. That is f of 0 is equals to limit x tends to 0, f of x is equals to limit x tends to 0, log of in bracket 1 plus ax minus log of 1 minus bx upon x, separate it. That is limit x tends to 0, log of 1 plus ax upon x minus log of 1 minus bx upon x. Therefore adjust here, that is the minus b multiplied to the numerator and the denominator. The value of this limit is 1 into a plus 1 into b, and overall you will get f of 0 is equals to a plus b, and hence option 1 is a correct one. Now next is, if for a GP m plus nth term is a p, m minus nth term is q, then mth term is p upon q, second in root of pq, see this here, we will see the answer of this. If for the GP m plus nth term is p, m minus nth term is q, then its a mth term is, that is a Tn is equals to, for the GP, a into r raised to n minus 1, T of m plus n is equals to a into r raised to m plus n minus 1 is equals to p. T of m minus n is equals to a into r raised to m minus n minus 1 is equals to q. Therefore here p is equals to q is equals to. Now take the ratio p upon q, a get cancelled. then you will get P upon Q is equals to R raised to M plus N minus 1 minus in bracket M minus N minus 1, and therefore you will get P upon Q is equals to R raised to 2N. Therefore the value of R is equals to P upon Q, that is equals to P upon Q raised to 1 upon 2N. Also P is equals to A into R raised to M plus N minus 1, and therefore if we substitute the value of R, which is P upon Q raised to M plus N minus 1, it is 1 upon 2N. Therefore the P is equals to A into P upon Q raised to M plus N minus 1 upon 2N. And if we simplify this, therefore you will get P into, that is a Q upon P raised to M plus N minus 1 upon 2N, that is equals to A. This is the value of the A. Now the mth term, that is a T suffix M, is equals to A into R raised to M minus N. Therefore now here again we will substitute the value of R, which is Q upon P raised to M plus N minus 1 upon 2N. This is the value of A. The value of A is a P into Q upon P raised to M plus N minus 1 upon 2N. And the value of this is the R, P upon Q raised to 1 upon 2N bracket raised to M minus N. If we substitute it, that is a P into Q raised to M plus N minus 1 upon 2N, P raised to M plus N minus 1 upon 2N into P raised to M minus 1 upon 2N, Q raised to M minus 1 upon 2N, and simplify this, that is a P into, that is a P raised to minus M plus N minus 1 upon 2N, P raised to M minus 1 upon 2N, Q into Q raised to M plus N minus 1 upon 2N, and the Q raised to minus M minus 1 upon 2N. Now simplify this, that is a P raised to M minus P raised to 1 minus M plus N minus 1 upon 2N into P raised to M minus 1 upon 2N, Q raised to M plus N minus 1 upon 2N minus M minus 1 upon 2N. And if you simplify this, it's very simple. Then you will get the answer of this. That is a P raised to 1 upon 2, Q raised to 1 upon 2. And that is nothing but the root of the PQ. Therefore, the options 2 is the second is the correct one. Question number 11. The value of integral minus 3 to plus 3 ax raised to 5 plus bx cube plus ax plus k dx, where a, b, c are constant, depends only on a, b and c, second a and b, third k, and fourth is a and k. Now I is equals to integral minus 3 to plus 3 ax raised to 5 plus bx cube plus cx plus k dx. Now their integration, normal integration is here. That is ax raised to 6 upon 6 plus bx raised to 4 upon 4 plus cx square upon 2 plus kx minus 3 to plus 3. Substitute the values. Therefore, you will get, once you put x is equals to 3 and next is x is equals to minus 3. Evaluate it. That is overall you will get, that is equals to 6k. Therefore, its value depends on the k. Then we will see your answer. That is if we solve it, then all the terms will be get cancelled. Only the plus 3k, and here is a minus will become plus, because here This is E1, E1, power is E1, power is E1. It will become plus. But overall in the bracket, outside the bracket, there is a minus sign. Therefore, this all will be get cancelled and only 3k plus 3k, that is a 6k. Its value depends on the k. Now next is question number 12. Which of the following equation has no solution? Cos of theta is equals to root 2. Second, sin theta is equals to minus 1 upon 5. Sec theta is equals to 23 and the tan theta is equals to 2019. Trigonometry functions their domain and the range. So y is equals to sin theta. Then its domain is a set of real number and the range, its values are lies between minus 1 to plus 1. Second, y is equals to cos theta. Then the domain is capital R. Its values again lies between minus 1 and plus 1. And third one is tan theta. Its domain is that is a capital R, set of real number minus 2n minus 1, 2n minus 1 into pi by 2, where n belongs to set of integers. This is the domain. And its range is set of real number. Cot of theta is equals to again, that is R minus n pi, where n belongs to set of integers. And its range is capital R. Y is equals to cosec theta, R minus 2n minus 1 into pi by 2, where n belongs to Z. R minus minus 1 and plus 1. And y is equals to sec theta, R minus n pi. N belongs to Z. R minus minus 1 and the plus 1. Therefore, that is the first cos of theta, that is equals to root 2. The values of cos theta lies between minus 1 and plus 1. Therefore, this is not the possible value. Now here see this, no solution, has no solution. This has no solution. This is the table which is given. Now next is the angle between lines x minus 2 upon 2, y minus 3 upon minus 2, z minus 5 upon 1 and x minus 2 upon 1 is equals to y minus 3 upon 1 is equals to z minus 5 upon 1 is 30 degree, 60 degree, 90 degree and 45 degree. Here A1 is equals to 2, B1 is minus 2, C1 is 1, A2 is 1, B2 is 2 and C2 is 2. The line x minus x1 upon E, y minus y1 upon B1, z minus z1 upon C1 and x minus x2 upon E2, y minus y2 upon B2, z minus z2 upon C2, where A1, B1, C1 and A2, B2, C2 are the direction ratios of the two lines. Then cos theta is equals to A1 into A2 plus B1 into B2 plus C1 into C2 upon in root of A1 square plus A2 square, A1 square plus B1 square plus C1 square into in root of A2 square plus B2 square plus C2 square. Substitute the value, that is a cos theta is equals to 2 into 1 plus minus 2 into 2 plus 1 into 2 upon in root of 2 square plus minus 2 square plus 1 square into 1 square plus 2 square plus 2 square, that is 0 upon, therefore the angle is 90 degree. Cos of theta is equals to 0. Option. Now see this here. These are the values. cos theta, their direction ratio. Substitute the values, then you will get cos of theta is equals to 0, and hence that is the theta is equals to 90 degree. Option 3 is the correct one. Now next is question number 14. If A is non-singular matrix such that A minus 2i into A minus 4i is equals to 0, then A plus 8 into A inverse is equals to, the first is I, second is 0, third is 6i, fourth is 3i. See this here. That is A minus in bracket 2i into A minus 4i, that's equals to 0. Now their product, A into A is, this is A square, minus 4ai is nothing but the 4a, minus 2ia, that is a minus 2a, plus 8i, that is equals to 0. Now simplify this, A square minus 6a plus 8i. Again multiply on both sides by A inverse. Therefore, you will get if you multiply it, then A inverse into A into A, minus 6 A inverse into A, plus 8 A inverse into I, that's equals to 0. And this is the I into A, minus 6i plus 8 into A inverse, and hence 6i is the answer. Now again, see this here simplification. This is the IA, that is A minus 6i plus 8 A inverse, that's equals to 0. Therefore, A plus 8 A inverse is equals to 6i, and therefore hence the answer is 6i. Hence option 3 is the correct one. Now the next is it is observed that the 25% of the cases related to child labor reported to the police station are solved. If the 6 new cases are reported, then the probability that at least 5 of them will be solved is, that is 1 upon 4 raised to 6, 19 upon 2048, 19 upon 1024, 19 upon 4096. Now here let x is equals to the number of the cases reported, p, the cases solved is at 25%, that is equals to 1 by 4. Therefore the value of the q is 1 minus p, that is equals to 1 minus 1 upon 4 is equals to 3 by 4. X follows the binomial distribution, n is equals to 6, p is equals to 1 upon 4, the probability mass function of x is the PMF of x is given as P of x, capital X is equals to small x, P of x is equals to 66, 1 upon 4 raised to x, 3 by 4, bracket raised to 6 minus x. PMF of x is given as P of x is equals to 66, 1 upon 4 raised to x, 3 by 4 raised to 6 minus x. The values of x is equals to 5 and 6. The probability that at least 5 of them must be solved, that is a P of capital X is greater than or equal to 5. It means that is a P of x is equals to 5 plus P of x is equals to 6. Now substitute the value here, that is x is equals to 5 and x is equals to 6. Then you will get the answer. Therefore option 4 is the correct one, that is a 19 upon 4096. You can see here. Okay. It is observed that the 25% of the cases related to the child labor reported to the police stations are solved. If the 6 new cases are reported, then the probability that at least 5 of them will be solved is, that x is equal to the number of the cases reported, p, the cases solved, that is the 25% is 1 by 4, and q is equals to 1 minus p, that is equals to 3 by 4. X follows the binomial distribution. N is equals to 6 and p is equals to 1 by 4. The productive mass function of x is given as p of x is equals to 6 is 6, 1 by 4 raised to x, 3 by 4 raised to 6 minus x. X is equals to 5 or 6, at least 5 is a. Therefore, probability that at least 5 of them is a sort means p of x, capital X, is greater than or equal to 5. Therefore, p of capital X is equals to 5 plus p of capital X is equals to 6. Substitute the value. 6 is 6, 1 by 4 raised to 5 into 3 by 4 raised to 6 minus 5 plus 6 is 6, 1 by 4 raised to 6 and 3 by 4 raised to 0. And that's why you will get 6 is 5 into 1 by 4 raised to 5 into 3 by 4 raised to 1 plus 1 by 4 raised to 6 into 1. And if we simplify this, then you will get, that is the 6 into 5 factorial upon 5 factorial, 1 by 4 raised to 6 into 3 plus 1 by 4 raised to 6. That is, take 1 by 4 raised to 6 as a common. 6 into 3 plus 1, that is 6 into 3 is 18, 18 plus 1 which is 19, and that is 1 by 4 raised to 6 into 19, that is a 19 upon 2 raised to 12, and that is equals to 19 upon 4096, and hence option 4 is the correct one. Now the next question is question number 16. If theta is equals to 17 pi upon 3, then the tan of theta minus cot theta is equals to, that is a minus 2 upon root 3, second 2 upon root 3, third is minus 1 upon 2 root 3, and the fourth is 1 upon 2 root 3. Now tan theta minus cot theta is equals to, that is the tan of 17 pi by 3 minus cot of 17 pi by 3, and this can be written as 5 pi plus 2 pi by 3. That is, it may be written as like this also, that is a 6 pi minus 5 by 5, 6 pi minus pi by 3 minus cot of 6 pi minus pi by 3. Now this goes in the fourth quadrant. That is, whenever the tan of 2 pi minus theta or 2 pi plus theta, the function remains as it is. Now it goes in fourth quadrant. In fourth quadrant, tan is a negative. Next is also minus, cot of minus pi by 3. That minus minus will become plus. Therefore, it is a 6 pi. It goes in fourth quadrant. Minus tan of pi by 3 plus cot of pi by 3. Substitute the value. That is minus root 3 plus 1 upon root 3. Therefore, you will get minus 2 upon root 3, and hence option first is correct one. And then you can see this answer of this. That is a theta is equals to 17 pi by 3. Find the value of tan theta minus cot theta. Tan theta minus cot theta, 17 pi by 3 minus cot of 17 pi by 3. That can be written as 6 pi minus pi by 3 divided with 3 to the 17. And that is a 6 pi minus pi by 3 minus cot of 6 pi minus pi by 3. The function remains as it is, minus tan of pi by 3 minus in bracket minus cot of pi by 3. That minus minus become plus. That is a minus root 3 plus 1 upon root 3. If we simplify, that is a minus 2 by root 3. And hence option first is correct one. That is a minus 2 upon root 3. Now the next problem is 17. the value of x in 0 to pi by 2 satisfying the equation sin x into cos x is equals to 1 by 4r pi by 12 5 pi by 12. Second is pi by 8 3 pi by 8. Third is pi by 8 pi by 4. Fourth is pi by 6 pi by 12. Now which are the values? Now we have the sin x into cos x is equals to 1 by 4. 2 sin x into cos x is equals to 1 upon 2. That is sin of 2x is equals to 1 upon 2. Therefore, the general solution of sin theta is equals to sin alpha is theta is equals to n pi plus minus 1 raised to n into alpha, where n belongs to z. Sin of 2x is equals to 1. That is we have here sin of 2x is equals to 1 upon 2. That is nothing but the sin of pi by 6. That is sin 30. Therefore, sin of 2x is equals to sin of pi by 6. Therefore, the required general solution is given by 2x is equals to n pi plus minus 1 raised to n into pi by 6, where n belongs to z. Therefore, x is equals to divide on both sides by 2. Therefore, x is equals to n pi upon 2 plus minus 1 raised to n into pi by 12, where n belongs to z. If n is equals to 1, then it is a 5 pi by 12, and hence where is a 5 pi by 2 option? That is a 5 pi by 2 option is for the first one. Therefore, I had selected that one. Now see this here. That is sin x into cos of x is equals to 1 by 4. 2 sin x into cos x is equals to 1 by 2. Therefore, sin of 2x is equals to 1. General solution, sin theta is equals to sin alpha is theta is equals to n pi plus minus 1 raised to n into alpha, where n belongs to z. Now we have here sin of 2x is equals to 1 upon 2. That is nothing but the sin of pi by 6. Therefore, 2x is equals to pi. That is 2x is equals to pi by 6. That is 2x is equals to n pi plus minus 1 raised to n into pi by 6. Divide on both sides by 2. X is equals to n pi upon 2 plus minus 1 raised to n into pi by 12, where n belongs to z. If n is equals to 1, then you will have that is a 5 pi by 12. That is I had done that is where is a 5 pi by 12 option? That is a 5 by 12 is only the for the first, and therefore the answer is that is a pi by 12 and the 5 pi by 12. Now the next is question number 18. If p x1 y1 is a point on the hyperbola x square minus y square is equals to a square, then sp into s dash p is equals to, that is x1 square plus y1 square upon a square, x1 square minus y1 square, x1 square plus y1 square. Fourth is x1 square minus y1 square upon a square. For more information, that is e is equals to, we will see our answer directly here from here. These are the options here. That is sp into s dash p. That is x1 square plus y1 square upon a square, x1 square minus y1 square, x1 square plus y1 square, and fourth is x1 square minus y1 square upon a square. That e is equals to in root of, for the hyperbola, a square plus b square upon a. Now here a and b both are the same. Therefore, the value of e is equals to root 2. That is in root of 2 a square upon a. That is root 2 into a upon a. A get cancelled. You will get e is equals to root 2. Again, the next is sp is equals to e times pm. Therefore, e in bracket x1 minus a upon e. Now simplify this, x1 e minus a. sp dash is equals to focal distance of p from s dash. That is equals to e into pm dash. Therefore, that is equals to e in bracket x1 plus a upon e. Now simplify this, sp dash is equals to e x1 plus a. Now their product, that is a x1 in mod of x1e minus a into x1e plus a, that is a minus b, a plus b, x1 square e square minus a square. Substitute the value of the e, then you will get 2x1 square minus a square. And again the value of a, which is given that at the point B is on the hyperbola, that is x1 square minus y1 square. If we simplify it, then you will get in mod of x1 square plus y1 square, and that is nothing but the sp into s dash p is equals to x1 square plus y1 square. That is the third option is the correct one. Now next is question number 19. If the length of transverse axis and the latus rectum of the hyperbola are 6 and 8 upon 3 respectively, then the equation of hyperbola is 4x square minus 9y square is equals to 72, 4x square minus 9y square is equals to 36, 9x square minus 4y square is equals to 36, and for this 9x square minus 4y square is equals to 72. This is the length of transverse axis, that is equals to 2a, that is equals to 6, therefore a is equals to 3. The length of latus rectum, that is equals to 2b square upon a, and therefore it is 8 upon 3. Substitute the value of a, then you will get b square is equals to 4, b is equals to 2. The required equation of the hyperbola is x square upon a square minus y square upon b square is equals to 1, that is x square upon 9 minus y square upon 4, that is equals to 1. And if we take the cross multiplication, then you will get 4x square minus 9y square is equals to 36, and hence option 2 is the correct one. Now again you can see the answer here. The length of the transverse axis and the latus rectum of a hyperbola is 6 and 8 upon 3 respectively. Then the equation of the hyperbola. Now these are the options. Length of the transverse axis is 2a, that is equals to 6, a is equals to 3. Length of the latus rectum, that is 2b square upon a, it is 8 upon 3. That is 2b square upon 3 is equals to 8 upon 3, b square is equals to 4, b is equals to 2. Required equation of the hyperbola is x square upon a square minus y square upon b square is equals to 1. Substitute the value of a and b, then you will get 4x square minus 9y square is equals to 36, and hence option 2 is the correct one. Now next is question number 20. G in bracket 3 minus 5r is the centroid of triangle ABC, where A 7 minus 8 1, B PQ 5, and C Q plus 1 5 P 0 are the vertices of triangle. Then the values of P, Q, R are respectively. These are the options. 3 minus 3 4 3, minus 4 5 4, minus 2 3 2, 6 5 4. Now the centroid, that is x is equals to x1 plus x2 plus x3 upon 3. Substitute the values, then you will get P plus Q is equals to 1, y is equals to y1 plus y2 plus y3 upon 3. Again minus 5 is equals to minus 8 plus Q plus 5P upon 3. Therefore minus 15 is equals to minus 8 plus 5P plus Q. That is a 5P plus Q is equals to minus 7. And third one is a P plus Q. And if you solve these two equations, then you will get the value of P and Q. And last is also there. That is a Z is equals to Z1 plus Z2 plus Z3 upon 3. Therefore, r is equals to 1 plus 5 plus 0 upon 3. 3r is equals to 6. R is equals to 2. The value of P is minus 2 and the Q is 3. Therefore, P is minus 2, Q is 3, R is equals to 2. Hence, option 3 is a correct one. Now again, you see here the answer. This is the question. If G 3 minus 5R is the center of the triangle here, A 7 minus 8 1, B PQ 5 and C Q plus 1 5P 0 are the vertices of triangle, then find the value of PQR respectively. These are the options 1, 2, 3, 4. Now x is equals to x1 plus x2 plus x3 upon 3. Substitute the value. Y is equals to y1 plus y2 plus y3 upon 3. And z is equals to z1 plus z2 plus z3 upon 3. Therefore, you will get p plus q is equals to 1. And from the next equation of the y coordinate, 5p plus q is equals to minus 7 and r is equals to 2. Now next is p plus q is equals to 1. 5p plus q is equals to minus 7. Therefore, p is equals to, that is a minus 2. Substitute the value of, that is a p. Then you will get q is equals to 1 minus in bracket minus 2. Q is equals to 3. Therefore, p is equals to minus 2. Q is equals to 3. R is equals to 2. These are the values and hence option 3 is the correct one. Now next is question number 21. A bag contains 6 white and 4 black balls. 2 balls are drawn at random. The probability that they are of the same color is 1 upon 15 to 5 upon 7, 1 upon 7, 7 upon 15. The total number of the balls are 6 plus 4, that is equals to 10. 2 balls are drawn at random. Therefore, n of s is equals to 10c2, 10 factorial upon 10 factorial minus 2 into 2 factorial. And that value comes to, that is equals to 45. N of s is equals to 45. The ball are of the same color. That is a n of a is equals to 4c2 plus 6c2. Therefore, 4 factorial upon 2 factorial into 2 factorial plus 6 factorial upon 4 factorial into 2 factorial. And if you calculate it, therefore you will get 6 plus 15, that is equals to 21. Therefore, n of a is equals to 20 and p of a is equals to n of a upon n of s. That is a 21 upon 45. That is 7 upon 15. P of a is equals to 7 upon 15. And hence option 4 is the correct one. Also, we see this here. A bag contains the 6 white and the 4 black balls. 2 balls are drawn at random. Then, the probability that they are of the same color. Okay, they are of the same color is 1 upon 15, 5 upon 7, 1 upon 7, 7 by 15. The total number of the balls. 2 balls are drawn at random. N of s is equals to 45. The ball are of the same color. N of a is equals to 4c2 plus 6c2. Add it, find out it. 6 plus 15. Therefore, n of a is equals to 21. Therefore, p of a probability of that is the ball of the same color. That is n of a upon n of s. That is the 21 upon 45, which is 7 upon 15. Therefore, p of a is equals to 7 upon 15. And hence, the fourth option, that is 7 upon 15, is a correct one. Now, next is question number 22. The order of differential equation of all circles whose radius is 4 is first is 2, second is 3, and third is 4, and fourth is 1. Now the equation of the circle with the center at HK and radius 4 is x minus h bracket square plus y minus k bracket square is equals to 4 square. And here there are the two arbitrary constants. Order will be the two. H and k are the arbitrary constant. Therefore, it's clear that its order is good. But how it is that I had given the solution? Differentiating with respect to x minus h bracket square, it's a derivative is a 2 in bracket x minus h. Derivative of y minus k bracket square is a 2 into y minus k into the derivative of y is dy by dx. That's equals to 0. And if we simplify it, that is a y minus k into dy by dx. That is equals to minus in bracket x minus h. This is the first. Now the second one is, now differentiate again with respect to x, then you will get, that is y minus k into d2y by dx square by you applying the product rule. Find out the derivative of dy by dx, which is a d2y by dx square plus. Now here again the derivative of y is a dy by dx into dy by dx, that is a dy by dx bracket square. That is equals to minus 1 y minus k into d2y by dx square plus dy by dx bracket square is equals to minus 1. And the value of, that is a y minus k into d2y by dx square, that is equals to dy by dx. That is minus 1 minus in minus 1 minus dy by dx bracket square. Take the minus sign as a common. Therefore, you will get y minus k is equals to minus in bracket 1 plus dy by dx bracket square upon d2y by dx square. From second, we get, substitute the value of both of the terms, that is the value of x minus h and the value of y minus k. Then you will get the required differential equation. That is the x minus h, that is equals to 1 plus dy by dx bracket square upon d2y by dx square into dy by dx. Substituting the value of x minus h and y minus k in equation 1, then you will get 1 plus dy by dx bracket square upon d2y by dx square into dy by dx bracket square, 1 plus dy by dx bracket square upon d2y by dx square bracket square is equals to 16. Simplify this. 1 plus dy by dx bracket square into dy by dx bracket square, 1 plus dy by dx bracket square whole square, that is equals to 16 into d2y by dx square bracket square. Therefore, the order of differential equation is clearly 2. Therefore, 1 plus dy by dx bracket square bracket is 2, 3. This is the required differential equation. Order is 2. Now again, you can see this answer. Equation of the circle with the center hk, radius is 4. X minus h bracket square plus y minus k bracket square is equals to 4 square. Differentiating with respect to x, that is a 2 in bracket x minus h plus 2 y minus k into dy by dx is equals to 0. That is y minus k into dy by dx is equals to minus in bracket x minus h. Again differentiating with respect to x, that is y minus k into d2y by dx square. Product rule apply there. dy by dx into dy by dx minus 1. Therefore, y minus k into d2y by dx square plus dy by dx bracket square is equals to minus 1. Y minus k into d2y by dx square, that is equals to minus 1 minus dy by dx bracket square. Therefore, the value of y minus k is equals to minus in bracket 1 plus dy by dx bracket square upon d2y by dx square. Therefore, from 2 you will get, that is a minus in bracket 1 plus dy by dx bracket square upon d2y by dx square into dy by dx is equals to minus in bracket x minus h. If we substitute it, then you will get the value of x minus h is equals to 1 plus dy by dx bracket square upon d2y by dx square into dy by dx, substituting the values of x minus h and y minus in equation 1. And after simplifying these two equations, you will get, that is the 1 plus dy by dx brackets square, take the common, then you will get dy by dx bracket square plus 1, and overall it will become the third power, that is 1 plus dy by dx bracket square raised to 3 is equals to 16 into d2y by dx square bracket square. Therefore, the order of differential equation is 2 here, and option 1 is the correct one. Now next is question number 23. If A, the matrix x1, 1, 0, A is equals to A inverse, then what is the value of x? First is 1. So this here. That is it. If A is equals to x1, 1, 0, A is equals to A inverse, then the value of x is. Now it's clear that A is equals to A inverse. Multiply on both sides by 3 multiplied by A, then you will get A square. That is A into A into A inverse. A into A inverse is I. A square is equals to I. Now substitute the value of A. That is x1, 1, 0, x1, 1, 0. That is 1, 0, 0, 1. Then if you take the product, it's x1, that is the first row, first column, you will get x square plus 1. First row, second column, that is x plus 0. And second row, first column, that is x. And last is 1. Therefore, if we compare these elements, corresponding elements, you will get x is equals to 0. And hence option 2 is the correct one. Next is 24. If f of x is equals to cos inverse of 1 minus log of x bracket square upon 1 plus log of x bracket square, then f dash of e. That is, first is 1 upon e, second is 2 upon e square, second is 1, third is 2 upon e square, fourth is 2 upon e. Let log of x is equals to tan of x, we substitute here. Therefore, f of x is equals to cos inverse in bracket 1 minus tan square x upon 1 plus tan square x. And if you solve it, then you will get, that is a cos square x minus sin square x upon cos square x upon sec square x. Therefore, cos inverse of, in bracket, cos square x minus sin square x. That is the cos square x and cos square x from the numerator and denominator get cancelled. You will get cos inverse of, in bracket, cos square x minus sin square x, cos inverse of cos of 2x, and that is y is equals to 2x. Now next, substitute the value of here x, that is x is equals to tan inverse of log of x, that is y is equals to 2 times tan inverse of log of x. Differentiate it with respect to x. Therefore, dy by dx is equals to 2 upon 1 plus log of x bracket square into ddx of log of x, which is 1 upon x. That is, dy by dx is equals to f dash of x is equals to 2 upon 2 in bracket 1 plus log of x bracket square. That is 2 upon 1 plus log of x bracket square into derivative of log of x, which is 1 upon e. Thus substituting the value, therefore you will get the answer 1 upon e. Now here again we will see there, that is, log of x is equals to tan of x, f of x is equals to cos inverse in bracket 1 minus tan square x upon 1 plus tan square x. F of x is equals to cos inverse 1 minus tan square x upon 1 plus tan square x. Now simplify this. That is a tan square x means what? Sin square x upon cos square x. That is, you will get cos square x minus sin square x upon cos square x whole divided by 1 plus tan square x is a sec square x. That is the cos inverse of cos square x minus sin square x upon cos square x into cos square x. Cos square get cancelled. You will get cos inverse of cos square x minus sin square x, which is nothing but the cos of 2x. Therefore, y is equals to 2x. But the log of x is equals to tan of x. X is equals to tan inverse of log of x. Substitute the value, that is that y is equals to 2x. That is the 2 tan inverse of log of x. Now differentiate this. dy by dx is equals to 2 upon 1 plus log of x bracket square into ddx of log of x, which is 1 upon x. Therefore, f dash of x is equals to 2 upon 1 plus log of x bracket square into 1 upon x. Now we want the value of log f dash of e. That is x is replaced by e, that is 2 upon 1 plus log of x bracket square into 1 upon e. That is a 2 upon, that is the log of e is 1, 1 plus 1 is, that is a 2 upon 1 plus 1, that is a 2. This 2 get cancelled, then you will get 1 upon e only. Therefore, f dash of e is equals to 1 upon e, and hence option first is the correct one. Now the next question. Question number 25. If x is equals to in root of a raised to sine inverse of t, y is equals to in root of a cos inverse of t, then find dy by dx. That is minus x upon y minus y upon x. Third is y upon x, and fourth is x upon y. X is equals to a raised to sine inverse of t, y is equals to in root of, a raised to cos inverse of t. Differentiate this. This is a parametric derivatives. Dx upon dt, ddt of in root of a sine inverse of t. That is 1 upon 2 in root of a raised to sine inverse of t into derivative of a sine inverse of t, which is a sine inverse of t into log of a into derivative of sine inverse of t. Now see this here, a sine inverse of t dy by dt 1 upon 2 times in root of a cos inverse of t into ddt of a cos inverse of t. That is 1 upon 2 in root of a raised to sine inverse of t into a raised to sine inverse of t into log of a into derivative of sine inverse of t. It's a 1 upon in root of 1 minus t square. Therefore, dy by dt is also therefore dy by dx is equals to dy by dt upon dx upon dt. Substitute the values of the dy by dt and the dx upon dt. Now the terms will get cancelled. Therefore, the remaining terms are a raised to cos inverse of t upon a raised to sine inverse of t into in root of a raised to sine inverse of t upon in root of a cos inverse of t. Therefore, you will get dy by dx is equals to in root of a raised to cos inverse of t upon in root of a sine inverse of t. Therefore, dy by dx is equals to minus y upon x. Therefore, option 2 is the correct one. That x is equals to a sine inverse of t, y is equals to a cos inverse of t. Their differentiation. Dx upon dt 1 upon 2 a sine inverse of t into ddt of a sine inverse of t. Dy by dt is 1 upon 2a in root of a cos inverse of t into ddt of a cos inverse of t. Dx upon dt is equals to 1 upon 2 in root of a sine inverse of t into a raised to sine inverse of t into log of a into derivative of sine inverse of t, which is 1 upon in root of 1 minus t square. Dy by dt is equals to minus 1 upon 2 times in root of a cos inverse of t into a raised to cos inverse of t into log of a into 1 upon in root of 1 minus t square. Therefore, dy by dx is equals to dy by dt upon dx upon dt. The terms will get cancelled. That is a minus a raised to cos inverse of t upon a sin inverse of t into in root of a raised to sin inverse of t upon in root of a cos inverse of t. Now this root and this is the first power, then you will get root of this quantity upon in root of a sin inverse of t, and that is nothing but the dy by dx is equals to minus y upon x. Option 2 is a correct one. Now the next is question number 26. The area of the region bounded by the curve y is equals to 2x minus x square and the line y is equals to x is dash dash square. Now here is a 1 upon 3, 1 upon 2, 7 upon 6 and fourth is 1 by 6. The equation of the curve can be written as, that is a parabola. It is inverted parabola of x square minus 2x plus 1 is equals to minus y plus 1, which is nothing but x minus 1 bracket square mine is equals to minus y minus 1. It is a parabola whose vertex is 1, 1 and it opens downward. To find the points of intersection of the curve y is equals to 2x minus x square, then the line y is equals to x. Equating the values of y from both the equations, we get x is equals to 2x minus x square, that is y is equals to x, and if you solve it, then you will get x is equals to 0 and x is equals to 1. When x is 1, y is 0, x is 0, y is 0. Now see this, the figure, that is a opens the downward that parabola whose vertex is 1, 1. It must have the curve a is a 1, 1. Now we'll find out the shaded region. This is that is the area below the parabola minus area below this line. Therefore, the required area is equals to 0 to 1 y dx minus 0 to 1 y dx, that is which is the line. This is the parabola whose equation is a 2x minus x square dx minus 0 to 1 x dx, that is the x square minus x cube upon 3 0 to 1 x square upon 2, that is the 1 minus 1 upon 3 minus 1 upon 2, which is 2 upon 3 minus 1 upon 2, and that is equals to 1 by 6. And again see this answer of this here, that is the area bounded by. The equation of the parabola can be written as x minus 1 bracket square minus in bracket y minus 1. It's a parabola whose vertex is 1, 1 and it is open downward. To find the point of intersection of the parabola and the line, put y is equals to x here. Then you will get x, 2x minus x square. Solve it. X in bracket x minus 1 is equals to 0, x is equals to 0 and x is equals to 1. When x is equals to 1, y is 0, x is equals to 0, y is 0, and therefore this is the required region to find out the area between the parabola and the line, and therefore the required area is 0 to 1 y dx minus 0 to 1 y dx of the line, that is 0 to 1 2x minus x square dx minus 0 to 1 x dx. Therefore x square minus x cube upon 3 0 to 1 minus x square upon 2 0 to 1, that is 1 minus 1 upon 3 minus 1 upon 2, which is the 2 upon 3 minus 1 upon 2, and that is equals to 1 by 6, and hence option 4th is a correct one. Now the next is question number 27. The equivalent forms of the statement that the negation of P implies negation of Q is P and Q, P and negation Q. Third is negation of P or Q, and fourth is P or negation of Q. Now here negation of P implies Q is a P and negation Q, and negation of P double implication Q, which is not asked, but I am giving here. There is a P and negation Q, or Q and negation of the P. Therefore, the negation of P implies negation Q is P and Q. This is the answer. The first option is the correct one. Again, you can see this answer also here. These are the two statements you have to remember. This is not required, but remember this also next time. May be asked for the negation of the double implication. That is, the negation of the double implication is equivalent to P and negation of Q, or Q and negation of the P. And negation of the implication is the P and negation of Q. Therefore, the negation of this is, that is the P, and negation of negation Q, that is a Q. Therefore, first option is the correct one. Next is question number 28. The general solution of the differential equation of all circles having center minus 1, 2 is x square plus y square minus x plus 2y plus c is equals to 0. X square plus y square minus 2x plus 4y plus c is equals to 0. X square plus y square plus 2x minus 4y plus c is equals to 0. X square plus y square plus x minus 2y plus c is equals to 0. And here is the general equation of the circle is x square plus y square plus 2gx plus 2fy plus c is equals to 0. If we compare all the options, that is, in 3 g is equals to 1, f is minus 2, and therefore the center is minus 1 and 2, and hence the option 3 is the correct one. X square plus y square plus 2x minus 4y plus c is equals to 0. Therefore, again, you can see this here. The general solution of the differential equation of all the circles having the center minus 1, 2 is, that is a general equation of the circle x square plus y square plus 2gx plus 2fy plus c is equals to 0. If we compare the third, that is a g is equals to 1, f is equals to minus 2, center is a minus 1, 2, and option 3 is the correct one. X square plus y square plus 2x minus 4y plus c is equals to 0. Now the next is question number 29. The equation of normal to the curve y is equals to x log of x to the base c at the point P 1, 0 is equation of the normal to the curve is 2x plus y is equals to 2, x minus 2y is equals to 1, third is x plus y is equals to 1, and fourth is x minus y is equals to 1. Therefore, here, that is a y is equals to log of x, its a derivative is a dy by dx is equals to 1 upon x. Dy by dx at 1, 0 is 1 upon 1 is 1, m is equals to 1. Slope of the normal minus 1 upon m, which is a minus 1. Equation of the normal is, that is a y minus y1 is equals to minus 1 upon m in bracket x minus x1. Substitute the value, and therefore you will get y minus 0 minus 1 in bracket x minus 1, that is x plus y is equals to 1. Therefore, option 3 is the correct one. Again, you can see this answer of this. The equation of the normal to the curve y is equals to log of x to the base c at the point 1, 0 is. Therefore, y is equals to log x. Dy by dx is equals to 1 upon x. At the point 1, 0, the slope is 1, m is equals to 1. Slope of the normal is minus 1. Equation of the normal, y minus y1 is equals to minus 1 upon m x minus x1. Substitute the value, y is equals to minus x plus 1, x plus y is equals to 1, and option 3 is the correct one. Now next is the value of tan inverse of 1 upon 3, tan inverse of 1 upon 5, plus tan inverse of 1 upon 7, tan inverse of 1 upon 8 is pi, 3 pi by 4, 5 by 4, and 11 pi by 5. Tan inverse of 1 by 3, tan inverse of 1 upon 5, tan inverse of 1 upon 7, tan inverse of 1 upon 8. That is, collect these two terms, tan inverse of 1 by 5 plus tan inverse of 1 upon 7 plus tan inverse of 1 by 3 plus tan inverse of 1 upon 8. Now apply the formula, tan inverse of x plus y upon 1 minus x into y. By using this formula, we will get, simplify this, that's the tan inverse of 7 plus 5 upon 35 minus 1 plus tan inverse of 8 plus 3, and that is equals to tan inverse of, this is the, therefore again applying the formula, tan inverse of that is 6 upon 17 plus tan inverse of 11 upon 23. That is the tan inverse of 6 upon 17 plus 11 upon 23 upon, that is, this is the tan inverse of 325 upon 325, tan inverse of 1, which is 5 by 4. And hence option 3 is the correct one. Now see this again. Tan inverse of 1 by 5 plus tan inverse of 1 upon 7 plus tan inverse of 1 by 3 plus tan inverse of 1 upon 8. Now solve this, tan inverse of 1 by 5 plus 1 upon 7. Then you will get, that is the tan inverse of 12 upon 34. Tan inverse of 1 by 3 plus 1 by 8 upon 1 minus 1 by 3 into 1 upon 8. Tan inverse of 3 plus 8 upon 24 minus 1, that is the tan inverse of 11 upon 23, and that is equals to tan inverse of 6 upon 17 plus tan inverse of 11 upon 23. That is the tan inverse of 6 upon 17 plus 11 upon 23 upon 1 minus 6 upon 17 into 11 upon 23. That is equals to tan inverse of 138 plus a 187 upon 391 minus 66. That is a tan inverse of 325 upon 325, that is 1. Tan inverse of 1, that is a pi by 4, and hence option 3 is the correct one. Now the 31. The equation of plane passing through the point minus 1 to 1 and perpendicular to the line joining points minus 3, 1, 2, 2, 3, 4 is, that is r bar dot in bracket 5i plus 2j plus 2k is equals to minus 1, r bar dot 5i minus 2j plus 2k is equals to minus 5, r bar dot 5i plus 2j plus 2k is equals to 1, and fourth is r bar dot 5i minus 2j minus 2k is equals to 1. The vector equation of the plane passing through the point A and perpendicular to n bar is r bar dot n bar is equals to a bar dot n bar. The required plane is passing through the point minus 1 to 1 and perpendicular to the line joining the point minus 3, 1, 2 and 2, 3, 4, that A bar is minus I plus 2j plus k, and B bar, that is a BC bar, that is C bar minus B bar, that is a 2i plus 3j plus 4k minus 3i plus j plus 2k, and that is equals to 5i plus 2j plus 2k BC bar. That is n bar is equals to A bar dot n bar is equals to, make their dot product, minus 1 into 5 plus 2 into 2 plus 1 into 2, that is equals to 1. Therefore, the equation of the required plane is R bar dot in bracket 5i plus 2j plus 2k is equals to 1, and hence option 3 is the correct one. See this again. The equation of the plane passing through the point and perpendicular to the line joining this. Therefore, the vector equation of the plane passing through this point and perpendicular to R bar dot n bar is equals to A bar dot n bar. The required plane passes through this point and perpendicular to this line. Therefore, the A bar is equals to minus I plus 2j plus k BC. Therefore, C bar minus D bar. Therefore, n bar is equals to 5i plus 2j plus 2k. Therefore, A bar dot n bar, its value is minus I plus 2j plus k, and its n 5i plus 2j plus 2k. If you take the product, you will get 1. The equation of the required plane is R bar dot in bracket 5i plus 2j plus 2k is equals to 1. Hence, option 3 is the correct one. Now, next is question number 32. The coordinate of foot of perpendicular drawn from the origin to the plane 2x minus y plus 5z minus 3 is equals to 0 are 2 upon root of 30 minus 1 upon root of 30, 5 upon root of 30. Second is 2 by 3 minus 1 by 3, 5 by 3, 2 minus 1, 5, and fourth is 1 by 5 minus 1 upon 10, 1 upon 2. The equation of plane is 2x minus y plus 5z minus 3 is equals to 0. That is 2x minus y plus 5z is equals to 3. That is 2x upon root of 30 minus 2 minus y upon root of 30 plus 5z upon root of 30 is equals to 3 upon root of 30. This is the normal form of the given equation. Hence, the direction cosines of the normal drawn from the origin to the given plane are L is equals to 2 upon root 30, M is equals to minus 1 upon root 30, N is equals to 5 upon root of 30. The plane is at a distance of 3 upon root 30 from the origin. P is equals to 3 upon root of 30. Therefore, the coordinates of the foot of perpendicular drawn from the origin are LP, MP, NP. That is LP is a 2 upon root 30, 3 upon root 30. That is equals to 6 upon 30 is equals to 1 upon 5. MP minus 1 by root 30, 3 upon root 30 minus 3 upon 30, that is minus 1 upon 10. NP, that is 5 upon root 30, 3 upon root 30, that is equals to 1 upon 2. And therefore 1 by 5 minus 1 upon 10, 1 upon 2. And hence the fourth option is the correct one. Now in the same way, the coordinate of the foot of the perpendicular drawn from the origin to the plane is 2x minus 5 plus 5z minus 3 is equals to 0 r. The equation of the plane is 2x minus 5 plus 5z minus 3 is equals to 0. And it can be written as that is a 2x minus 5 plus 5z is equals to 3 divided on both sides. That is a root 30 means 5 square plus 1 square plus 4 square. That is a total is a 30. And hence divide by the root 30 to the on the both sides. This is the normal form of the given equation. Hence the direction cosines of the normal drawn from the origin to the given plane are L is equals to 2 upon root 30, M is equals to minus 1 upon root of 30, N is equals to 5 upon root 30. The plane is at a distance of 3 upon root of 30 from the origin. Therefore, P is equals to 3 upon root 30. Therefore, the coordinate of the foot of the perpendicular drawn from the origin are LP, MP, NP. Substitute the value and hence you will get the value of LP, MP, NP is 1 upon 5 minus 1 upon 10 and 1 upon 2. And hence the option 4th is a correct one. Now the next is question number 33. Integral 0 to 4 dx upon 1 plus root x into dx. And the 2 times is dx there. These are the options. Which one is the correct one? I will solve this integral. That is, let I is equals to integral 0 to 4 1 upon 1 plus root x into dx. Root x is equals to t, therefore x is equals to t square, therefore dx is equals to 2t into dt. When x is 0, t is 0. When x is equal, t is a 2. Therefore 0 to 2, 2t into dt upon 1 plus t. That is a 2 times 0 to 2, 1 plus t minus 1 upon 1 plus t dt. Therefore 2 times 0 to 2, 1 minus 1 upon 1 plus t into dt. That is a t minus log of mod of 1 plus t, 0 to t, 2. Substitute after upper limit and the lower limit. Then you will get that is a 4 minus 2 log of 3. And this 4 can be written as that is a log of e raised to 4. To the base is also e there. And 2 log of 3 can be written as log of 3 square. Therefore, that is equals to log of e raised to 4 upon 3 square. That is equals to log of e raised to 4 upon 9. And hence, the option 2 is a correct one. Question number 34. Now again, you can see this answer. That is 0 to 4 dx upon 1 plus root x dx. Log of e raised to 4 upon 3. Second, log of e raised to 4 upon 9. Third is log of e raised to 3 upon 4. And fourth is log of e raised to 4 upon 6. Let I is equals to 0 to 4. 1 upon 1 plus root x into dx. Root x is equals to t, x is equals to t square, dx is equals to 2t into dt. Now the limits, when x is equals to 0, t is equals to 0. When x is equals to 4, t is equals to 2. Therefore, I is equals to integral 0 to 2, 2t into dt upon 1 plus t. That is a 2, 0 to 2, 1 plus t minus 1 upon 1 plus t into dt. Separate it. That is a 2 times integral 0 to 2, 1 minus 1 upon 1 plus t into dt. The integral of 1 is t minus log of mod of 1 plus t into 0 to t. 0 to 2. That is substitute upper limit and lower limit. That is a 2 minus log of 3 minus 0. Log of 1. That is a 4 minus 2 times log of 3. That is a log of e raised to 4 minus log of 3 raised to 2. Log of e raised to 4 upon 3 square. That is a log of e raised to 4 upon 9. Therefore, the option second is correct. Now next is question number 34. If the line passes through the points 6 minus 1 to q 8 7 lambda 8 7 8 minus 7 to lambda and r 5 to 4, then the value of the lambda. It's a very simple question. If you find out the direction ratios and equate it, then you will get the value of the lambda. Now here the direction ratios of PQ, that is a 8 minus 6 minus 7 minus in bracket minus 1. Next is a 2 lambda minus 2, that is a 2 minus 6, 2 lambda minus 2. And the direction ratios of PR, that is a 5 minus 6, 2 minus in bracket minus 1, 4 minus 2, minus 1, 3, 2. And therefore, since the points PQ are the collinear, the direction ratios of PQ and PR are the same, and therefore 2 lambda minus 2 upon 2 minus 6 upon 3, that we equate it, find out the value, therefore the lambda is equals to minus 1. Therefore option second is correct. You can see this also here. If the line passes through the points P 6 minus 1 to Q 8 minus 7 to lambda and R 5 to 4, then the value of the lambda is minus 3 minus 1 0 2. The direction ratios of the PQ, that is a 2 minus 6 to lambda minus 2. Direction ratios of the PR, that is a minus 1 3 2. Since PQR are the collinear, the direction ratios of the PQ and the PR are in the same proportion, and that's why here is a 2 lambda minus 2 upon 2 is equals to minus 6 upon 3, and evaluate this, you will get the value of the lambda, that is equals to minus 1, and hence option 2 is a correct one. Now next question, question number 35. The statement pattern P and Q and negation of R or P and Q or negation of P or Q is equivalent to, the first is R, second is P, third is Q, fourth is P and Q. So P and Q and negation of R or P and Q or negation of P. Now we'll evaluate like this. There is a P, there is a 3 statement. For the P we take the 4T 4F, Q, TF, TF, TF. That is a double T, double F, double T, double F. And R is TF, 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 and evaluate it. Next find out the P and Q. Now form the table. And therefore find out the negation of P and Q. That is a Q, it's something but the Q. Hence option 3 is the correct one. In the same way, follow here. This is the Now the next question is the joint equation of pair of straight lines passing through origin and having the slope 1 plus root 2 and 1 upon 1 plus root 2 each. These are the options. Now the equation of a line passes through the origin is y is equals to mx, that is y is equals to 1 plus root 2 into x, and y is equals to 1 upon 1 plus root 2 into x. Now evaluate this. The first is 1 plus root 2 into x minus y, and second is x minus in bracket 1 plus root 2 into y is equals to 0. The joint equation is that is equals to 0. Their multiplication is equals to. Now the next is divide on both sides by 1 plus root 2. Evaluate it. Multiply numerator and the denominator to the middle term, it's a conjugate, that is 1 minus root 2. Then you will get x square minus 2 root 2 xy plus y square, that is equals to 0, and hence option 3 is the correct one. Simple. So you can see this here also. This is the options. Equation of the line passing through their joint equation. Simplification is important here. Multiplication 1 plus root 2 bracket square, expand it, divide on the both sides 1 plus root 2, then you will get, that is multiplied to the numerator and denominator by 1 by root 2, then you will get 1 minus 2, therefore it is a minus 1. If you solve this, that is the x square minus 4 plus 2 root 2 into minus 1 minus root 2 into xy upon minus 1 plus y square, and simplify this. Then you will get x square plus in square bracket 4 minus 4 root 2 plus 2 root 2 minus 4 bracket complete into xy plus y square is equals to 0. X square minus 2 root 2 xy plus y square is equals to 0, and hence the option 3 is the correct one. Now the next question. Question number 37. The joint equation of the lines passing through the origin and trisecting the first quadrant is x square plus root 3 xy minus y square is equals to 0. Root 3 x square minus 4 xy plus root 3 y square is equals to 0. X square minus root 3 xy minus y square is equals to 0. Fourth, 3x square minus y square is equals to 0. Now see this here. The lines are trisecting the first quadrant. Therefore, the angle made by the first line is 30. Second line is 60. Theta 1 is 30. Theta 2 is 60. Therefore, the slope of line L1 is theta 1 is equals to 30. M1 is tan of 30. That is 1 upon root 30. Slope of line L2 is theta 2 is equals to 60. M2 is tan 60, that is a root 3. Equation of L1 and L2, that is a y is equals to m1x and y is equals to m2x. Substitute the values. Therefore, you will get y is equals to 1 upon root 3x and y is equals to root 3x. And therefore, x is equals to root 3y and root 3x minus y is equals to 0. Therefore, the joint equation of the lines are, that is x minus root 3y into root 3x minus y is equals to 0. Therefore, root 3x square minus xy minus 3xy plus root 3y square is equals to 0. Simplify this, that is root 3x square minus 4xy plus root 3y square is equals to 0, and hence the option second is correct one. Now the next is the joint equation of the lines passing through the origin and trisecting the first quadrant. Now see this, these are the two lines making an angle of 30 and 60. It trisects, means 30, 30, 30. It makes the unequal angles, that is 30, 30, 30. Division in the three equal parts. Therefore, the slope of the line L1, where the theta 1 is 30, M1 is tan of 30, that is equals to 1 upon root 3, and second is theta 2. M2 is equals to tan 60, that is equals to root 3. Equation of L1 and L2, y is equals to M1x, y is equals to M2x, y is equals to 1 upon root 3x, and y is equals to root 3x. Simplify it. X minus root 3y is equals to 0 and root 3x minus y is equals to 0. The joint equation is x minus root 3y into root 3x minus y is equals to 0. And their product, root 3x square minus xy minus 3xy plus root 3y square is equals to 0. Root 3x square minus 4xy plus root 3y square is equals to 0. And hence option second is correct one. Now the next is question number 31. Which of the following function is not continuous at x is equals to 0? F of x is equals to 1 plus 2x, bracket is to 1 upon x, x is not equals to 0. And that is f of 0 is equals to e square. Second is f of x is equals to e raised to 1 upon x minus 1 upon e raised to 1 upon x plus 1 for x is not equals to 0. And that is minus 1, x is equals to 0. Third, f of x is equals to sin x minus cos x, and x is not equals to 0. And that is equals to minus 1 for x is equals to 0. And fourth one, f of x is equals to e raised to 5x minus e raised to 2x upon sine of 3x for x is equals to 0. That is first, we solve this limit, that is equals to e square. Therefore, the second is, now to evaluate this limit, f of 0 is minus 1. We take the left hand side limit, e raised to 1 upon x minus 1. Limit x tends to 0, e raised to 1 upon x minus 1, e raised to 1 upon x plus 1. Left hand side limit, as h tends to 0, e raised to 1 upon 0 minus h minus 1, e raised to 1 upon 0 minus h plus 1. That is the limit h tends to 0, e raised to minus 1 upon h minus 1, e raised to minus 1 upon h plus 1. Limit h tends to 0, and that is equal. As h tends to 0, that is 1 upon e raised to infinity minus 1, that is equals to minus 1. And therefore the given function is continuous. Third is f of x is equals to sin x minus cos x. X is not equals to 0. And if we take as x tends to 0, then you will get the minus 1. Therefore, the given function is a continuous at x is equals to 0. Fourth one, limit x tends to 0, e raised to 5x minus e raised to 2x upon sine of 3x, e raised to 5x minus 1 upon 5 minus 3 upon 3, 5 minus 2 upon 3, and small mistake, that is equals to f of 0. All functions are here continuous. I think that there is a mistake in this paper by my knowledge. Okay. And now we'll see this here. This is the, I think that the question is wrong. F of 0 is 1 and not minus 1. This is the correction. Therefore, if you see this, the value of this limit is e square. Therefore, the given function is a continuous. And for the second, that limit is minus 1. Therefore, it is also continuous. If we solve this limit, that is the limit, left hand side limit x tends to 0, sorry, x tends to left hand side limit e raised to 1 upon x minus 1, e raised to 1 upon x plus 1, h tends to 0, e raised to 1 upon 0 minus h minus 1 upon e raised to 1 upon 0 minus h plus 1. Evaluate it, and therefore you will get h tends to 0, e raised to minus 1 upon h minus 1, e raised to minus 1 upon h plus 1. And if we solve this, therefore then you will get, that is the 1 upon e raised to 1 upon 0. 1 upon 0 is infinity, therefore 1 upon e raised to infinity minus 1. 1 upon e raised to infinity plus 1, that is a minus 1. And therefore it is a minus 1. But the f of 0 is 1. We have given that in the f of 0, that is equals to minus 1. Therefore this is also a continuous function. And the next is, this is also continuous function because the limit is equals to the value of the function. The last is also continuous function. All functions are continuous. Therefore, I think that there is a mistake in this problem. I had solved in my definition. You may check anywhere. Now the next question is, all the functions are continuous. Question number 39. If cumulative distribution function is given by capital F of x is equals to x minus 25 upon 10, then P of x where lies between 27 and 33. Therefore, P of x lies between 27 and 33, f of 33 minus f of 27, and substitute the value in that function, then you will get, that is the 3 upon 5, that is equals to 3 upon 5. In the same way, see this here, the CD of capital F of x, x minus 25 upon 10, there are the values 33 and 27, 8 upon 10 minus 2 upon 10, 6 upon 10, 3 by 5, and hence the answer is 3 by 5. Hence the second option is the correct one. Now next is question number 40. derivative of log of x to the base e square, that is the derivative of log of x to the base e square with respect to x is, that is the 2 upon log of x, 1 upon x into log of x square, 3 upon 2 upon log of x into log of x, and fourth 1 upon x log x. Let y is equals to log of x to the base e square. Now change the base, that is the log of x and log of e square. Therefore y is equals to log x, differentiate with respect to x, dy by dx is equals to 1 upon 2 times log of x into ddx of log of x. That is a 2 x into log of x, that is the derivative of log of x is 1 upon x, therefore dy by dx is equals to 1 upon 2x into log of x, and that is nothing but the x into log, that is 1 upon x into log of x square. The second option is the correct one. Derivative of this, change in the base, that is the log of x, log of e square, that is the log of e square means 2 times log of e, that is 2, differentiate with respect to x, dy by dx, which is a break there, that is the log of x upon 2 times log of, that is a 2 into 1, therefore overall that is a 2. Now differentiate this with respect to x, that is the dy by dx is equals to 1 upon 2 times log of x into ddx of log of x. Log of x is a 1 upon x, that is the dy by dx is equals to 1 upon 2, 1 upon x into log of x square. Hence option second is the correct one. Now next is question number 41. A random variable x has following probability distribution. Capital X is equals to the small x and p of x, that is 1 capital X. The values of the capital X are 1, 2, 3, 4, 5, 6, and p of x k, 3k, 5k, 7k, 8k. That is sum of the all k plus 3k, 5k, 7k, 8k plus k. That is a 25k is equals to 1, k is equals to 1 upon 25. P of x lies between 2 to 5, p of 2, 3, 4. Substitute. That is 3k, 5k, 7k. That is a 15k, 15 into 1 upon 25, that is a 3 by 5. In the same way, we have this, that is a sum of the all is equals to k, k is equals to 1 upon 25. We want to find out the question is, that is the probability of p of capital X. P of x lies between 2 to 5, equal to 2 and less than 5. That is a 2, 3, 4. That is a 2 is a 3k, 5k, 7k, 15k. That is a 15 into 1 upon 25. That is a 3 by 5. And hence the fourth option is the correct one. Now next is 42. For a GP, if Sn is equals to 4 raised to n minus 3 raised to n upon 3 raised to n, then T2 is, it's very simple question. From the 11th standard, Tn is equals to Sn minus 1. That is T2 is equals to S2 minus S1. Substitute the value. Therefore, you will get that is T2 is equals to 4 upon 9. This is the answer. Now, again, you can see this here. Tn is equals to Sn minus 1. T2 is equals to S2 minus S1. Substitute the value. Then you will get T2 is equals to 4 upon 9. Option 3 is the correct one. Now, next is a stone is dropped into a pond. Waves in the form of circles are generated and radius of outer ripple increases at the rate of 5 cm per second. Then the area increased after 2 seconds is. The first is 50 cm per second, second is 100 pi centimeter square per second, third is 25 centimeter square per second, and fourth is 40 centimeter square per second. Now we have dr upon dt. The radius is increasing at the rate of 5 centimeter per second. That is when t is equals to 0, the radius r is equals to 0. When t is equals to 2, then the radius is increasing at the rate of 5 centimeter per second. That is when t is equals to 2, then 5 into 2, that is equals to 10 centimeter. That is at the end of the 2 seconds, the radius will be 10 centimeter. Therefore, A is equals to pi r square. dA upon dt is equals to 2 pi r into dr upon dt. Substitute the values. Then you will get that is a 2 pi r, that is a 2 pi 10 dr upon dt, that is equals to 5. Therefore, 100 pi centimeter square per second. That is 100 pi centimeter square per second. Also, you can see here, stone is dropped into a pond. Waves in the form of the circles are generated and the radius of the outer ripple increases at the rate of 5 centimeter per second. The area increases after the 2 seconds. We have dr upon dt 5 centimeter per second. When r is equals t is equals to 0, radius is 0. When t is equals to 2, that r is equals to 2 into 5, that is a 10 centimeter. A is equals to pi r square. dA upon dt is equals to 2 pi r into dr upon dt. That is a 2 pi 10 into 5. That is the dA upon dt is equals to 100 pi centimeter square per second. That is equals to 100 pi centimeter square per second. Now the next question is, in triangle ABC with usual notation, if cos of A is equals to sin B upon sin C, very interesting problem, then the triangle is, that is an acute angle, triangle. Second is obtuse angle triangle. Third is equilateral triangle. Fourth is right angle triangle. Therefore, cos of A is equals to sin B upon sin C, and by using the sine rule now, that is sin of A upon small a, sin of B upon small b, sin of C upon small c. Therefore, sin of capital B upon sin of capital C is equals to. That is, this ratio can be written as sin of B, capital B upon small b is equals to sin of capital C upon small c. Therefore, sin of capital B upon sin of capital C is equals to B upon C. And that is equals to cos of A is equals to b square plus c square minus a square upon 2bc. And that's why substitute the value. That is what is the value of sine of b upon sine c is a b upon c. And cos of a is equals to b square plus c square minus a square upon 2bc. And therefore cancellations. That is a 2b square is equals to b square plus c square minus a square. That is a 2b square minus a square is equals to c square minus a square. And c square is equals to b square plus a square. Now what is the cos of capital C is equals to b square plus c a square plus b square minus c square upon 2 ab. Substitute the value. That is cos of capital C is equals to 0. Therefore the triangle ABC is a right angle triangle. Therefore the fourth option is a correct one. That is a triangle is a right angle triangle. Now again see this here. That is cos of A is equals to sine of B upon sine C by the sine rule. Sine A upon A, sine of B upon B, sine of C upon C. Sine of capital B upon sine of capital C is equals to B upon C. Cos of A is equals to B square plus C square minus A square upon 2BC. Cos of A is equals to B upon C. Cancellation of the CC, then you will get that is a 2B into B, that is a 2B square is equals to b square plus c square minus a square. 2b square minus a square is equals to c square minus a square. C square is equals to b square plus a square. Now cos of capital C is equals to a square plus b square minus c square. Substitute the value of a square plus b square, which is the c square. C square minus c square is 0. Cos of capital C is equals to 0. Therefore triangle ABC is a right angle triangle. Hence option 4 is the correct one. Now next is problem number 45. Integral cos of x plus x sin x upon x square plus x cos x into dx. Now again this is an interesting problem. The answer is log of mod of x sin x upon x plus cos x. Second is log of mod of x square plus x cos x plus c. Third is log of mod of cos x plus x sin x, and fourth is log of x upon x plus cos x plus c. That is the cos x plus x sin x upon x square. Now see this integration. It is written in this manner. That is the plus x and minus x. Separate it. That is the cos x plus x sin x plus x minus x. Take x as a common from this, and then you will get that is the cos x plus x sin x minus 1 upon x in bracket x plus cos x dx. Separate it. That is the integral in square bracket 1 upon x plus sin x minus 1 upon x plus cos x dx. And integral of 1 upon x is log of mod of x. And again here sin of x and minus 1. The derivative of x is 1 and cos of x is minus sin x. Take minus sin is common from these two. Then you will get the form f dash of x upon f of x. That is nothing but the log of mod of f of x. Now see this here. Take minus sin as a common. That is log of mod of x minus 1 minus sin x upon x plus cos x. That is log of mod of x minus log of mod of x plus cos x plus c. And overall x upon x plus cos x plus c. Therefore the fourth option is the correct one. Plus c. Now the next is a question number 46. Again you can see this here. One thing is adjusted here, plus x and minus x, cos of x plus x, and take x as a common, then you will get that is the x sin of x minus 1. Separate it. that is cos of x plus x upon x in bracket x plus cos of x, then you will get 1 upon x plus. Next it is sin of x minus 1 into x, and then again x will get cancelled, sin of x minus 1 upon x plus cos of x. Therefore, you will get log of mod of x plus integral sin of x minus 1 upon x plus cos of x dx. Next, take minus sin as common, then you will integral 1 minus sin x upon x plus cos x dx. Therefore, log of mod of x minus integral 1 minus sin x upon x plus cos x dx. And its integration is log of mod of x minus log of mod of x plus cos of x plus c, and hence this answer. And the fourth option is the correct one, that is a log of mod of x upon x plus cos of x plus c. And the next is if p bar, q bar, r bar are the non-zero, non-coplanar vectors, then p bar plus q bar minus r bar, p bar minus q bar minus r bar is equals to what? Now these are the options. Then we want to evaluate this box product. It's very simple. That is the p bar plus q bar minus r bar dot in bracket. That is b bar cross c bar. That is p bar minus q bar into q bar minus r bar. Now we will perform their product, p bar cross q bar minus p bar cross r bar minus q bar cross q bar plus q bar cross r bar, that is in bracket. Therefore, q bar cross q bar, that is 0. Now these things are remaining only. See this again here. Q bar cross q bar, that is 0. Therefore, p bar cross q bar minus p bar cross r bar, q bar cross r bar. Now again their product, p bar into this p bar cross q bar, that will be 0 because p is a common there. For the next is p is also common there, and for third is p bar dot in bracket q bar cross r bar. This is for the next q bar, and again here q is common, therefore that will be 0. This is present, again this will be 0. And for the r bar, p bar cross q bar, this will 0 and last will be 0. Whenever there is a repeated of the terms, repeated of the vectors, then it is a 0. That is the p bar. Now again you can see this here. Product manner. That is the p bar in bracket p bar plus q bar minus r bar, bracket complete, in square bracket p bar cross q bar minus p bar cross r bar plus q bar cross r bar, and evaluate this p. Here is the p is common, that will be 0. P bar dot in bracket q bar cross r bar. Next, this is a q, this will become 0. That is a q bar dot in bracket p bar cross r bar, and again this will become 0. Next is r, that is a minus r bar dot in bracket p bar cross q bar. This will become 0, last will be also 0. Therefore, what are the present here? P bar dot in bracket q bar cross r bar plus. Now here is a q bar dot in bracket p bar cross r bar. We can change here. It can be written as, that is r bar cross p bar. And then we will write it in this manner. That is a QRP. That is in cyclic order, it is written as p bar dot in bracket q bar cross r bar. And last is minus p bar dot in bracket q bar cross r bar. These two will become 0. Only the remaining term is a p bar dot in bracket q bar cross r bar. That is nothing but the box product p bar q bar r bar. And the hence option 1 is the correct one. Number 47. That is integral dx upon 1 upon x square plus 1 bracket square. It's a very simple integration. Here we will substitute that is x is equals to tan theta. These are the options. Put x is equals to integral 1 upon x square plus 1 bracket square into dx. Put x is equals to tan theta. Then dx is equals to sec square theta into d theta. Integral I is equals to sec square theta into d theta upon tan square theta plus 1 bracket square integral sec square theta into d theta sec raised to 4. Tan square theta plus 1 means what? Sec raised to 4 theta. Sec square theta and bracket square, it is sec raised to 4 theta. Therefore, cos square theta. Now, what's here? That is sec square theta upon sec raised to 4 theta. Sec square get cancelled. You will get 1 upon cos square theta. 1 upon sec square theta. It becomes cos square theta into d theta. And that is equals to cos square theta. Now, there is one more standard result. What is the cos square is? Cos square is equals to 1 plus cos of a upon 2. That is a 1 upon 2 in bracket 1 plus cos of 2 times theta. And evaluate this very simple integration. That is 1 upon 2 theta plus sine of 2 times theta upon 2 plus c. As theta is equals to x is equals to tan of theta. Therefore, sine of 2 times theta is equals to 2 tan theta upon 1 plus tan square theta. Therefore, 1 upon 2 tan of theta. That is a tan in x is equals to, one thing is that is a 2 sine of 2 times theta is equals to 2x upon 1 plus x square. Next is also one thing is remaining. Theta is equals to tan inverse of x. This was remaining. That is a tan inverse of x plus 1 upon 2 tan inverse of x plus x upon x square plus 1 plus c. 1 upon 2 tan inverse of x plus 1 upon 2 x upon x square plus 1 plus c. Therefore, option first is the correct one. Therefore, I is equals to integral 1 upon x square plus 1 bracket square dx is equals to tan theta dx is equals to sec square theta into d theta. I is equals to integral sec square theta into d theta tan square theta plus 1 bracket square. Tan square theta plus 1 means what? Sec raised to 4 theta. And therefore, you will get 1 upon cos square theta, that will be 1 upon sec square theta, that will become cos square theta. That is 1 upon 2, 1 plus cos of 2 times theta into d theta. That is 1 upon 2. Their integration, integral of 1 with respect to theta is theta. Sine of 2 times theta upon 2 plus c. X is equals to tan theta. Sine of 2 theta is equals to 2x upon 1 plus x square. That is a sine of 2 times theta is equals to 2 tan theta upon 1 plus tan square theta. And hence, here is a theta is equals to also tan inverse of x, and therefore 1 upon 2 tan inverse of x plus x upon x square plus 1 plus c. And hence, that is the I is equals to 1 upon 2 tan inverse of x plus 1 upon 2 into x upon x square plus 1 plus c. And hence option 1 is the correct one. Question number 48. The maximum value of z is equals to 9x plus 11y subject to 3x plus 2y less than or equal to 12, 2x plus 3y less than or equal to 12, where x is greater than or equal to 0, y is greater than or equal to 0 is 48, 54, 44, 36. Now see this here. 3x plus 2y is equals to 12, 2x plus 3y is equals to 12. Both of them have the same value, equal to 8. When the first equation, that is a 3x plus 2y is equals to 12, when it touches the x-axis, y is equals to 0, therefore x is equals to 4 is, and when it touches the y-axis, x is 0, therefore the coordinate is a y is equals to 6, that is a 0, 6, and therefore this is the line 3x plus 2y is equals to 12. That is C is a 6, 0, 0, 4. Next equation. For this equation, when it touches the x-axis, 2x is equals to 12 and it is a 6, 0. When it touches the y-axis, x is 0, that is 0, 4. This is the point of intersection. Phi x is equals to 0, therefore phi x is equals to 12, therefore x is equals to 12 upon 5. And so y is equals to 36 upon, that is 12 upon 5, y is equals to, both of them have the same value. We'll calculate. Z is equals to 9x plus 11y, that is equals to 48. At 40, its value is 9x plus 11y. At 04, it is a 44, and hence option 1 is the correct one, which is the 48. Again, see this here. This is the point of intersection. Now page is breaking there. X is equals to 12 upon 5. Y is equals to 12 upon 5. And check it. At the 12 upon 5, we have the 48. Z, 40. Its coordinates, x is 4, y is 0. We'll get 36 and 04, 44. Option first is correct one, which is the 48. (49) P 2 2 Q minus 2 4 R 3 4 are the vertices of triangle PQR. Then the equation of the median through R is very simple question. This is the question from the 9th standard, I think. These are the M is the midpoint whose coordinate is the midpoint of PQ, which is 0 3. R is 3 2. Slope of MR, that is 4 minus 3 upon 3 minus 0, which is 1 upon 3. Equation of the MR, y minus y1 is equals to m times x minus x1. Y minus 3 is equals to 1 upon 3 in bracket x minus 0. 3y minus 9 is equals to x. X minus 3y plus 9 is equals to 0. Option 2 is the correct one. Also, you can see this here. This is the median. Rn is the median. M is the midpoint. Midpoint, that is a 0 3. M is 0 3. R is a 3 4. Therefore, the equation of the MR, y minus y1 is equals to m in bracket x minus x1. Y minus 3 is equals to 1 upon 3 in bracket x minus 0. 3y minus 9 is equals to x. X minus 3y plus 9 is equals to 0. Option 2 is the correct one. Now the next is question number 50. If A is equals to, in curly bracket, x belongs to set of real number x square minus 5 mod of x plus 6 is equals to 0, then n of A. How many solutions will be there for that quadratic equation? That is x square plus 5x plus 6, when x is the first is, see this here, case 1, mod of x is greater than or equal to 0, mod of x is equals to x. Solve this quadratic equation, x square minus 5x plus 6, you will get x is equals to 2, x is equals to 3. When x is negative, mod of x is equals to minus x, then you will get x is equals to minus 2, minus 3. X is equals to plus or minus 3, x is equals to plus or minus 3, plus or minus 2. The total number of the solutions are 4, hence option 3 is the correct one. Now again, you can see this here also.
That is case 1 is important. When mod of x is greater than or equal to 0, mod of x is equals to x square. Therefore, this equation mod of x is equals to x square minus 5x plus 6, x minus 2, x minus 3. Solve that. X is equals to 2, x is equals to 3. Case 2, when x is less than 0, mod of x is minus x. Now this minus minus will become plus. That is x square plus 5x plus 6. X is equals to minus 2, x is equals to minus 3. Therefore, there are the two values, x is equals to plus or minus 2, x is equals to plus or minus 3, and of a is equals to 4. Hence, the option 3 is the correct one. This is the. In this way, we have completed the first paper of the last year CET, that is first day, first sheet paper. I hope that you will have understood all the explanation, whatever that I had explained. Now we'll see in the next paper. Till then, goodbye. असं मला वाटते की तुम्हाला बऱ्यापैकी समजलेलं असेलच मी काय जे एक्सप्लेन केलं असेल ते. हा पहिल्या दिवसाचा पहिल्या शिफ्टचा पेपर होता. यानंतर आपण पुढच्या व्हिडिओमध्ये पुढचा पेपर बघणार. टिल देन गुड बाय.